viewers. I welcome you to our contextual analysis of science and mathematics education. Which topic are we looking at today? We are going to be looking at energy, how to calculate energy, and under the subject physics. As usual, my name is Chidimi Adeomelati Babatunde. I will be teaching you today on how to calculate energy. Before we go further, kindly subscribe to my YouTube channel. If you like this today's program, subscribe to the channels how to calculate energy, so you'll be able to see more on this one. But before we dive into the topics, I want us to look at our learning objective. What are the things are we going to be learning in today's program? Let's look at the learning objective. At the end of it, we'll be able to learn what is energy. We'll be able to look at the forms of energy we have, different forms of energy that we have. We then move on to look at energy conversion, how energy can be changed from one form to another. We now look at how to calculate the forms of energy that we want to look at. Let's go over the topics again. Now, what do you call energy? From the word energy, energy has to be related with work done. What is energy? We can say energy is ability to do work. Your ability to perform work is called what? Energy. And energy is measured in joule. That is why they normally say energy and work done are the same thing. Because work done is in joule, energy is also in joule, which is the unit of energy. Like you all know, in physics, we have to put unit. Everything is being measured in a particular unit. So the unit of energy is what? Joule. Having said that, we have defined what is energy, which is ability to do work, as our first learning objective. Let us now look at different forms of energy that we have. One of them is called, we have mechanical energy, we have the electrical energy, we have the heat energy, we have the sound energy, we have what? Electrical energy and the rest. You can see on the board forms of energy: mechanical energy, we have heat energy, we have sound energy, we have electrical energy, we have chemical energy, we have nuclear energy. Likewise, we also have what? Solar energy. The solar energy is the energy that combines the light and the heat together. So combination of heat and light give us what? Solar energy, energy from the sun. Having said that, let us now look at conversion of energy. According to the law of conservation of energy, it says that energy is neither created nor destroyed, but energy can be converted from one form to another. So energy is neither created nor destroyed, but can be changed or converted from one form to another. What do you mean by this statement? This statement means that we can change electrical to heat, we can change sound to heat, we can change electrical to sound from one form to another. We have on the board, like I wrote here, we have electrical energy to sound energy. That takes place in loudspeaker. Energy conversion from electrical energy to sound energy is in loudspeaker. Another one, we can change mechanical energy to electrical energy in our generator or dynamo. In dynamo or generator, energy conversion is mechanical energy to electrical energy. Also, we have chemical energy can be converted to electrical energy in the battery or in the car battery. Chemical energy is changed to electrical energy. What about another one? We can change electrical energy to what? Heat energy. That happens in electric cooker. So forms of energy conversion in electric cooker is electrical energy to heat energy. So we can see that energy can change from one form to another. Most of our appliances, our household material that we normally use at home, there is a lot of energy conversion in them. If you look at our ceiling fan, the fan, there is energy conversion there. So that's what we are saying. So energy can change from one form to another. Having said that, let us now look at our last learning objective called how to calculate forms of energy. In this area, we are going to be looking at the two main forms of energy, of mechanical energy, which are electrical and potential energy. So the two main forms of mechanical energy, which are electrical energy and potential energy, these are the ones we want to calculate. Having said that, what do we call kinetic energy? Let's take the two forms of mechanical energy. The two forms of mechanical energy are potential energy and kinetic energy. Okay, what is potential energy? Potential energy can say energy of position. This is the energy of position. Okay, and what is the formula of calculating potential energy? We have what is called M multiplied by G multiplied by H. What is M? M is the mass. Mass. Okay, our G, acceleration. Acceleration is our G. What about our H? Stands for height. So these are the three things involved in calculation of potential energy. Multiply your mass times your acceleration due to gravity multiplied by your height. Now, having said that, what about kinetic energy? KE. Kinetic energy. This is the energy of motion. Energy of motion. When you say the word kinetic, kinetic have to do with what? Movement, motion. Okay, so what is the formula of calculating kinetic energy? Formula of calculating kinetic energy is half times mass times v squared. So in this formula, what does M stand for? Our M stands for the mass. Mass. M is mass. Okay. Our V stands for velocity. Velocity or the speed. Specify direction. So these are the formula of calculating the two main forms of mechanical energy. For the potential and for the what? Kinetic. Having said that, let us now look at an example, a question on how to calculate potential energy and kinetic energy. Let's look at a question. We have a question on our hand that says, a man of mass 4 kilograms jump down from a height of 14 meters. Okay, you now say find its potential energy. Find its potential energy. Given that our acceleration due to gravity is 10 meters per second square, although it varies, but in this case, we want to use 10 meters per second square as our acceleration due to gravity. Is under what? Motion. That area. Now, a man of mass 4 kilograms, that's the mass, jump down from a height of 14 meters. We should find the potential energy. Stop potential energy position. So back to our formula of calculating potential energy. Simply say our M multiplied by G multiplied by our H. Okay. What is our M in the question? Our mass is 4 kilograms. Our G, we are to give it 10 meters per second square. 10 mc square. Okay. What about our H? The height. The height given is 14 meters. Okay, so back to the formula, potential energy just from M mass. What is our mass given? 4. Multiplied by our G, 10. Multiplied by 14. What do we have? 4 times 10 is 40. 40 times 14 will give us what? 560. 560 joule. That is the energy, potential energy of the man. So that's how to calculate the potential energy. Your mass multiplied gravity, which is 10 meters per second square, multiplied by the height. Okay, so that's how to calculate potential energy. Now let's go further. Then let us look at the second one, how to calculate kinetic energy. Now, you've seen how to calculate potential energy. What about our kinetic energy? So for the kinetic energy, let's look at the question. The question says a bullet of mass 2 kilogram moves with a speed, that is the velocity, moves with a speed of 100 meter per second. We now say find its kinetic energy. You are being told to calculate the kinetic energy of a bullet of mass 2 kg, 2 kilogram, move with a speed, that is the velocity there is of 10 meter per second square. So back to our formula, just say our kinetic energy as usual is half times mass times velocity square. So now say half multiplied by our mass. Our mass in the equation is 2 kilogram multiplied by the velocity 100 square, giving us half times 2 times 100 times 100 in two places because it is square. So 2 cancel 2. What do we have there? 100 times 100, giving us 10,000. So we are going to have 10,000 joule. That is the kinetic energy of the bullet. So that's how to find the kinetic energy, find the potential energy. Now, what about the world energy resources? The world energy resources, we can see that energy resources can be of two types. We have what is called renewable energies, renewable resources, renewable resources of energy. We also have non-renewable resources. So these renewable resources are the areas where the energy we generated can still be we can reuse it. But non-renewable, these are the forms of energy that we can renew. When we use it, it's finished. So when you look at renewable resources, these are the ones you can renew again. We have what's called, we have the solar, sun, you can renew it. We have the wind. We also have what's called water. Water, you can reuse water as a form of energy. You can use wind. You can use solar. All these ones are renewable resources, energy resources. What about non-renewable? These are the ones, when being used, when being taken, you can't get them back. The moment you finish using them, that is the end. You can't replace them back. Example, natural gas. Natural gas, okay, is non-renewable. Petroleum, okay. Also have the nuclear energy. So all these ones, the moment you finish using them, you can't replace them back. The non-renewable. Renewable, you can get them back and see them. So we are able to cover all our learning objectives. We have defined what is energy. We have looked at forms of energy. We have looked at energy conversion under the law of conservation of energy. Likewise, we also look at the energy resources, both renewable and non-renewable. And we have concluded to how to calculate forms of energy, how to calculate kinetic energy, how to calculate potential energy. So this is where we are going to stop today. If you enjoyed today's class, kindly subscribe to my YouTube channel, press the button, let me hear your comments, your views on today's topic, so that in the next program, we can be able to see more on the edition we are going to do. So if you enjoyed today's program, we normally treat chemistry, physics, biology, and mathematics on this channel. When you subscribe, you see all the other subject and topic we normally do and what we have done before. Comment, let me see your comment. And my email, you can reach me at lateefadeomi100@gmail.com if you have any comment or any observation. So I still remain Lateef Adeomi Babatunde. I say remain scientifically intelligent. Bye bye. Thank you.